Another application here would be a fragment screening, for example. Fragments are inherently binding with very low affinities and are having quite quick rates. Also, we were able, together with a partner here with Roche, able to measure a library of around 500 fragments of very small size that bind to a 25 kilodalton target protein that was amine coupled in this case onto the sensor surface here to several densities, and then we're screening a whole library of fragments binding to it. You can see here that's a normalized response plot that you would get directly from the wave control software, that where you can put in your thresholds and you can normalize your signals, your binding signals, of course, to a positive control. As you can see here in red, the positive control signal is normalized to 1, and it's repeatedly injected over the whole course of the experiment to take control over target or ligand degradation over time, and we can normalize for that. Additionally, what we did is we ran the whole assay, the whole screening a second time, and you see on the correlation plot on the right-hand side that actually we get a really nice correlation here between the two independent measurements and assays. Such a screen here with 531 fragments can be carried out in 2 to 2.5 days. Not without demobilization here, and that is hands-off measuring time. So that's a really automated picking up of samples and subsequently injecting the fragments onto the surface. Another example here where we were interested into very quick kinetics, and that is THT, a small molecule binding to fibrils, actually amyloid fibrils, which we, in this case, immobilized onto a PCZ surface. That's a special surface, a special wave chip you can order directly that has more balanced negative and positive charges. So it's a zwitterionic surface. We were able to immobilize decent amounts of these fibrils, and then I think almost for the first time see as the THT binding to it. And again, on the full sensorgram, on the full plot here, you see it's almost looking like bulk shifts, and as there were no curvatures here. However, if you zoom into these regions, you see that we get nice curvature, and that we can reliably and robustly fit the data to a one-to-one model, giving very high rates. Again, here we're talking about an off rate of almost 11 per second.